Okay guys, so this is our second part. Okay, this is our second part of our number system lecture. Okay, so now let's we were in root n plus 1 minus root n minus 1 upon 2. Okay, so what is the meaning of this? What is the meaning of this? Okay, so we were in that part. No, we were in that part like one second. One second, we were in that part here. Root n minus 1. Okay, so the formula we've written on that is the formula is like a minus b. Okay, means here b plus a into a minus b. Okay, so this is the formulas. It is a formula on that basis that was written, which I've studied, or which I taught, or which I written on the board in our previous class. Okay, so this is the formula. I think you have to note this formula. Note it down. Note it down with me. Note it down, this formula. Okay, pause the video and note it down. Okay, let's move to the next part. We will not waste our single time because time and tide waits for none. Okay, so here root n plus 1, root n plus 1 minus root n minus 1 minus root n minus 1 by 2. Okay, root n minus 1 minus root n plus 1 minus root n minus 1. Okay, so this by 2. So this is, I don't know what they're trying to say. What they're trying to say, I don't know. We have to understand what they're trying to say. Okay, so here is a question. N minus 1, n plus 1, n minus 1 by 2. What is the meaning of this? So they are trying to say that a minus b by 2. A minus b by 2. A means this one. A means whole this one is the a. Whole this one is the a. And whole this one is the b. And this is 2. We all know. A minus b by 2. Now what should I do? I have nothing to do. I have nothing to do. Okay, this comes. So that means okay. So this is we are moving to next one. I hope no. No, we have to understand this part. We have to understand this part. Then we can move to our next line or next statement. We have to understand first. Okay, let's think. I am also thinking. What is the meaning of this part? I am also thinking. I don't know. I couldn't understand. I think this is a formula. Okay, if this is a formula, then we cannot do anything. This is a formula, I think. This is a formula. A minus b by 2, a minus b by 2, and the formula is the previous we have written. I think that's formula. So we have nothing to do with this formula part because formula has its own thing, own concept. So we have nothing to do with formula. Okay, so now this means root n plus 1 minus root n minus 1 is also rational. Is also rational. Is also rational. Okay. So in the same way, if their minus value, like if their minus value is rational, then they are also rational. Means the connecting theorem, or connecting, but not theorem, connecting pattern they are matching from connecting logic. Like this logic, if this is, then this is. Okay, if this is not, then that is not. Okay, so this is how they are connecting one logic to another logic. Okay, this that is how the questions or mathematics prove one concept or one question or one problem. Okay, so the connection of one logic to another logic. Okay, so that's root n minus 1 and root n plus 1 are also rational. Okay, are also rational. So root n minus 1 into and root n plus 1 are also what is rational. They are also rational. Okay, so this is not possible. Any two perfect square differ at least by 3. Here, hence there is no positive integer n such that root n is rational. Okay, n minus 1, root n minus 1 and root n plus 1 are also rational. Then they are saying, okay, I am removing it. I hope you guys noted it. Okay, I hope you guys noted it. I am removing it. So they are saying this is not possible. This is not possible. This is not possible. This is not possible as any two perfect squares differ at least by 3. Okay, hence there is no positive integer, hence there is no positive integer n such that root n minus 1, yeah, my ink is going into an end here, root n minus 1 plus root n plus 1 is rational. Okay, so they're saying that, okay, is my writings are visible? Okay, they're saying that this is not possible. This is not possible as any two perfect square differ at least by 3. So what we have to find out is that the question was that we have to find all positive integers from which positive integers means we have to find the n. We have to find the n so that this 2, so that root n minus 1 plus root n plus 1, their answer or their additional value will their additional value is rational, so that their additional value is rational. Okay, so now the question here arises that root n minus 1 and okay, so there is rational such that, okay, so we have to find that they are rational. Okay, so this is not possible as any two perfect squares differ at least by 3. Okay, this is not possible as any two perfect squares differs at least by 3, hence there is no positive integer such n such that is rational. Oh my god. This question is something different here. This question is actually something different. This one is something, I think my knowledge or my conceptual clarity is lagging. That's why we are facing, or I am facing some difficulties to understand this question, the solution. You know, something is lagging. That's why we are not understanding the question. The question is absolutely brilliant, but something is lagging us. Something is lagging. That's why we are not. Hence, this is not possible as any two perfect square differ at least by 3. What is the meaning of this line? What is the meaning of this? Differ at least by 3. What is the meaning? Oh, what is the meaning? We are pointing out. What is the meaning? What is the solution is trying to say that this is not possible as any two perfect square. Okay, what are the two perfect square? Is this the two perfect square? They're trying to say us, they're trying to tell us that these are the two perfect squares. Is there? Are there two perfect? Are there two perfect square? What do you think? And they're saying this is not possible as these two perfect square differ at least by 3. Means their difference they're trying to say the difference, that is n minus 1, sorry, n minus 1 plus root n plus 1. their difference. If these two particles, so that means their difference. Okay, the difference is equal to 3. So this is not possible. This is not possible. They are saying this is not possible. Okay, so that's why. So that's why there is no positive integers. That's why there is no positive integers in such that root n minus 1 plus root. Something is lagging here. Something is lagging here. I think where something lagging. I think our knowledge is lagging. That's why we are facing difficulties to understand the concept or the answer. Now what should I do or what should we? Okay, we are leaving this question. I am leaving this question. Okay, we will do it later. We are leaving. Okay, we are leaving this question. I'm not getting understand what is what they're trying to say. What they're trying to say. Okay, 1 second. Give me 1 second. Okay, give me 1 minute. 1 second. You guys also think. I'm also thinking. Okay guys, here is one correction. Here is one correction. These are not the two perfect square. Okay, here is one correction. Okay, so these are not two perfect square. Okay, I'm removing this whole thing. We have to solve or we have to understand this question and the solution here. We have no any other way. Okay, suppose they're saying n minus 1 and n plus 1 perfect square. They are the perfect square. Okay, they are this n minus 1 and this n plus 1, they are perfect squares. Their difference is equal to 3 is not possible. The difference is equal to 3 is not possible. Hence there is no positive integer. Okay, I couldn't understand what is they're trying to say, that their difference should be 3. Difference should be 3. I don't know what they're trying to say. If their difference is not 3, then there is no positive integer n such that root n minus 1 plus root n plus 1 is rational. Why? Why? No, tell me why. Suppose root n plus 1 minus root n minus 1 is also rational. Okay, then n plus 1 root n minus 1 are also rational. Do one thing. Now do one thing. We have to become desperate for our solution here. We have to become desperate. Suppose n minus 1 whole square minus n plus 1 whole square. N minus 1 whole square plus n plus 1 whole square. Okay, so let's do one thing. N square minus 2n plus 1 square minus n square plus 2n plus 1. Done. I hope you guys understand. Okay, we are done. Now okay, we are removing the bracket. No, not bracket. This is, suppose n square minus 2n plus 1 n square plus 2n plus 1. This one is cut out, this one is cut out, this one is cut out, this one is cut out. N square minus 2n plus 1 n square plus 2n plus 1 minus cut out okay, 1 second, minus 4n minus 1 minus 4. Okay. Suppose 1 by xn is equal to minus 4n. Okay, minus 4n minus 4n and x1 is equal to minus 4n into xn. And this xn is equal to, okay, I'm removing this whole thing. I'm just solving, okay, I'm just trying to understand what they're trying to say. So minus 4n 1 upon xn is equal to minus 4n. Okay, so now 1 is equal to minus 4n into xn. So this becomes 1 upon 4n is equal to xn minus. So we have got this value. Okay, we have got this value, that is minus 1 upon 4n is equal to xn. Here this value 1 upon 4 means what? 1 upon 4 means, suppose 0.25. Okay, minus 0.25 no, we what are we doing? 0.25 by n. 0.25 by n. Okay, so that means 0.25 by n. That means it is much lesser than 3. Okay, I don't know I'm correct, right or wrong. I just tried. Okay, so please don't mind. I'm also not getting understand what's the meaning of their solution. Okay, what they're trying to actually say. The question is clear for me. The question is clear, but the answer of the solution is not clear. Okay, I'm not getting understand what the solution actually trying to show. What the solution actually trying to, I'm not getting clear. So here the 0.25 by n. So that means n 0.25 by n which is 1. I don't know. So at the one conclusion, I don't know this is correct or wrong. 0.25 by n. So here something we are getting that n is much lesser than 3. So that's why they are not positive. N is not positive integer. Okay. Okay, we will do it later. We will do it later. Okay. We will do it later. Surely we will do it later. So this is for today. Thank you for joining in. Thank you for giving me support. So we will meet tomorrow. So bye bye. Take care.